Welcome to the weekly update dated September 17th, 2021 for the 5-minute production GitLab Incubation project. My name is Shri and I'll begin with a short recap. 5-minute production aims to make non-Kubernetes deployments trivial from GitLab. And we have in the past already proven that non-Kubernetes deployments and stateful infrastructure can be managed within GitLab. Now, in pursuit of an excellent user experience, we have prioritized one-click authentication and authorization, one-click configuration, and the targeted first rollout is to support non-Kubernetes review applications in gitlab.com. This week, progress was made in two areas. One, feature flagging, and the next was researching Auth and credential setup for Google Cloud. Feature flagging, it was an amazing experience to use what's already there. So the idea here was to put all the incubation work that I'm doing behind a feature flag so that I can merge my small MRs into the main code base in small iterations, right? That was the idea. So I looked at the documentation and it's just the developers and the tech writers have just done an amazing job with this. What should have taken me half a day took me less than 30 minutes. Amazing. Next up was researching Auth and config. Those of you who follow this project are aware that this topic came up earlier this year. In the past, we were looking at the AWS Auth and config implementation by Vantage.sh. Vantage.sh has created a CloudFormation template that generates AWS keys and posts these keys to their callback URL for persistence. The user experience involves the user opening a pop-up window that is deep linked to this particular CloudFormation template. So the user would naturally face the AWS console login screen, and assuming they choose to proceed, so they log in, they go to the template, and they can add it to their account. So the user has this option to install the template, and upon this installation and execution, the template would create the AWS keys and send them back to a callback URL. This allows Vantage.sh to perform AWS console requests on behalf of the users. While this is a very clever implementation by Vantage, it does have some drawbacks. And the drawbacks are basically working around the lack of OAuth offered by AWS. To my best knowledge, AWS simply does not allow users to log in via a third-party application. Thus, when a user must grant rights to a third-party application, it involves the manual process of setting up the keys and then copying them over. This leads to hacks such as the one Vantage created. And while it is extremely clever, the user experience is just not perfect. There is a pop-up window opened. This pop-up window does not auto-close when the job is done. The user is not guided through the process, nor any useful prompts being shown. Google Cloud does not have these limitations. Google offers OAuth 2 and cloud-related scopes for OAuth 2, in addition to cloud APIs that allows users to authorize a third-party app, such as GitLab, to perform operations on their cloud resources. Here's the system setup to get this working. We have two actors. We have GitLab and we have Google Cloud. GitLab needs to be registered as a Google OAuth 2 application. That means we set up credentials, callback URLs, and the API entitlements. The required scopes are Cloud Platform, and we enable the Cloud Resource Manager and the IAM APIs. Once the systems have been set up, the user workflow comes into effect. Here we have three actors. We have the user, who is a user of GitLab and a user of Google Cloud. The user wants to deploy their GitLab project to Google Cloud. So they will select the Auth with Google button within their GitLab project. GitLab would then redirect the user to Google. Google asks the user to log in with their credentials. Assuming the user does that, the next question Google will pose is, do you authorize GitLab to manage your cloud resources? And assuming the user approves that as well, Google then redirects the user back to GitLab. Once GitLab has been authorized, GitLab would generate service accounts and service account keys for the user. These service account keys would be then stored as GitLab CI/CD variables, and GitLab pipelines now have the credential to deploy to Google Cloud. Let's have a look at this flow in action. I built a small prototype web application to test this out. Last week, I showed you a front-end concept that introduces within the GitLab settings CI/CD, it introduces this button to authenticate with Google. So the demo that I show you on the right, I want you to imagine that it's actually taking place in this section out here. So the user presses the button, clicks the link, which takes them to the standard Google OAuth login screen. I select my account, and now Google says, hey Shri, do you want to allow this application to manage your cloud data? The user can of course cancel. So I cancel that, and that this is a case that needs to be handled. Let's say the user tries again, and this time they will not cancel, but they will grant the permissions. So I say allow, and now once allowed, GitLab is showing me the list of my Google Cloud projects. I select the project that I want associated with my GitLab project. And once this is done, a service account and service account key is created. If I switch to my Google Cloud console, you will see that I hit refresh, and the service account that just got generated, which is a GitLab generated service account, it's right here. It's available. If I go inside the service account and I go to the keys, the key is active as well. Let me just delete this because I've shown you in plain text on my screen, so I don't want this around. But now this key, this is the one that should be persisted inside GitLab CI/CD variables. And with that, a GitLab pipeline has the permissions to deploy this project onto the user's Google Cloud account. To recap, what we just saw was a third-party web application, eventually the GitLab Rails web application. This application was authorized by a Google user. Once authorized, it was able to create and store deployment credentials for that user. This process was not a hack. We used proper APIs that are documented, supported, and secured by Google. And the user experience did not involve any pop-ups or any other invasive quirks. It was as straightforward and natural as can be. This opens the door for a clean integration of GitLab with Google Cloud. That means a GitLab project is linked to a Google Cloud project. GitLab would be the store of deployment tokens, and thus GitLab would be the source of all deployments performed on this project. It's a significant responsibility to undertake on behalf of GitLab and GCP users. This type of integration, especially with something like Google Cloud, is of course high profile and involves strategic decisions. So my focus in the next few days would be to build consensus within my team, whether we go down this route or not. And if we are going down this route, to prepare implementation architecture with proper threat modeling, and best practices in place so that it can be reviewed by the engineering leaders that we have here, because I am aware that this is a big responsibility that we are going to have to do.